This is Computing Up, conversations about computation writ large with Michael Littman and Dave Ackley. This episode was recorded October 26th, 2023.
Hi, Dave. Do you listen to audiobooks?
I haven't. I listened to a chunk of The Martian because it was available free at one point when I was like trying Amazon, blah, 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 blah. And I never heard the end of it. And that's my only experience so far. Why do you ask?
Oh, so I really want to do an audiobook version of my book.
Cool.
And the publisher's like,
Really?
Yeah. So I might have to produce it myself.
I get it. Wow.
Yeah.
I mean, I hear it's big business. I hear that lots of people listen to books.
I mean, I do because reading is a drag. So I'd like to either when I'm commuting or on the exercise device, like it makes sense to just like keep the information flowing inward.
Right. No, I get it. It seems to me a lot of people listen to books or videos or whatever it is when they're doing their exercises.
Yeah. Okay. Well, just curious.
Yeah. I've been curious about it, but I haven't gotten in there. And
are you still a good reader though? Like presumably you do books.
Not nearly as much as I used to, because I'm more output focused. And, so I end up reading crap up and down the net all the time, but just little bits and pieces of things. I mean, so like I've been working my way through Small is Beautiful, for about 6 months, reading like 10 minutes while I'm having lunch.
That's not the one about people should live in smaller houses.
No, that's the one about economics as if people mattered.
Ooh.
That's the subtitle. It's from back in the 70s. And one of our previous guests and I connected on it. And to my shame, I actually hadn't read it. So I've been, I knew a little bit about it and everything. So I've been actually reading it. It's really pretty good. And this is a guy that knows about agriculture and interprets everything in terms of the system that we're all part of and just points out the obvious, like we treat oil as if it's renewable and it's not. And we treat the sun as if it's capital, which it's not, and so on and so forth. So anyway,
really
but that's an example, and that's one of the very rare cases where I'm actually reading nonfiction, like that. So
yeah, I mostly read nonfiction.
I usually my slogan is I don't have time for nonfiction. Because nonfiction is really all this kind of, it's got this pompousness about it that, I'm telling you truth. So you have to pay attention to me. You have to care. Whereas fiction is humble. And so because, it's just make believe. Let's play along. It's as if. So everybody gets invited to come along and you can actually learn much more about how minds work, how thoughts work, how people work by seeing how people put stories together, by seeing what they put into their characters' minds, by seeing what they put into the world around the characters. So anyway.
I tried to write a pompous book, but it ended up being more comedy focused.
Well, pompous is good if you're going for comedy. As long as it's, you're making fun of the pompousness, then you're there.
That's good.
I end up getting pretty pompous sometimes too. And every time I can manage to puncture that, like that, whatever it is I'm working on gets so much better. Because I get pompous because I'm afraid people won't take me seriously. And so I want to make it like, oh, you should. I'm so authoritative. But in fact, that just puts people off. And if it's like, I think I'm completely crazy, but if you have nothing else to do, let me tell you this one thing. Like that.
Gotcha. Well, okay. So speaking of your output, and in particular, speaking of this notion of the obvious, which you just mentioned, I watched your new video that answers all the questions.
The theory of everything.
The theory of everything. And
Yeah.
and you being a person who's so dedicated to theory in general, I thought that was a particularly exciting thing to do.
Okay, you got me right off the bat. So what should I have called it? The
No, theory of
implementation of
everything is
everything.
theory of everything is great. And also, what's it? Unified theory is another phrase that people often
Right,
use.
grand unified
Grand
theory.
unified theory. And so there are
Yeah.
folks in artificial intelligence and robotics who are like, we need a grand theory of machine learning and artificial intelligence. And I'm like, I don't think so. I don't know that it's that kind of thing. But a
Yeah.
theory of everything, like you addressed a couple different questions that are like the big questions that people have been grappling with since people have been writing stuff down. So first of all, kudos
Well,
on
thanks.
taking that on, because that's not a light lift.
Yeah. And again, it's that punch of pompousness that makes it possible to take on such things. It doesn't make it possible to pull it off necessarily, but it makes it possible to take it on.
So let's tell people a little bit about this. I definitely encourage people to give it a watch, because it's an hour, I think, and
Yep.
it moves along well, and it's a little bit off the cuff. It's not super polished, so people can just you really feel like kind of Dave is laying it out for you, and I've had many wonderful experiences over my professional career of Dave laying things out for me. So it felt great to me. So I
You can
definitely
be
would
like
recommend
Michael.
it. Yeah, that's right. I've had a pretty good life. Join me.
Okay, thank you.
So maybe we could get into it a little bit. So remind us
All right.
what the questions are that make up the theory of everything, and
Okay.
maybe we can talk about the basic premise, what you've come to think about after you've done this, and then maybe I can like poke at it a little bit and get some more reactions out of you.
I want to don't miss that part. That's
Okay.
the part I want the most. So yeah, so it seems obvious to me that people would like to have an explanation for everything.
Okay.
That seems kind of self-evident to me.
And you had three levels. I don't know that everybody lives their life that way, but definitely there's plenty of people who do. And I think that there's even the people who don't, there's a hunger to have an answer, even if they haven't asked the question.
Yeah, and I think so the way I kind of put it is every thoughtful person at some point during their lives is going to think about this stuff and going to think about, is there a systematic, no bullshit way to figure this stuff out? Or is it all just this patch of this trick and that trick, and there's no actual overriding pattern to any of it, that kind of thing. And I was
you structured it around some questions though.
Yeah. So I mean, and they're, obviously they're not my questions. They're everybody has had them since forever. But the way I framed it was, why are we here? And, Jesus, I can't even remember my questions. What is our purpose? Maybe we
where do we go next?
And the last one is, what do we do now? So it's, why am I here? Where did I come from? Why am I here? And the last one is, what do we do now? And I can't believe that I don't have these at the tip of my tongue. It's as if I didn't know we were going to talk about this.
So sorry.
But
that was the gist of it. And so if you're not remembering it, it's because the details are not the important part. The important part is that different kinds of answers have been proposed over the years.
Right. And okay, so where do we come from? Why are we here? What makes us special? And what should we do now? Those are the four questions. And
the four questions is good. That's like a Judaism thing.
Oh yeah,
yeah. Every year on Passover, there's four questions. You got to like remind yourself what the questions are. Sometimes you have to look at the slides, and then you have the youngest person there read the answers so that they're forced to kind of contend with them. I would totally do a Dave Theory of Everything Seder. That would be pretty cool.
Well, I mean, I think that especially with the part about the youngest one reading the answers, that kind of fits into the overall story here.
Right, because the way that you framed it is you talked about young Dave, and you actually had pictures of young Dave. I'd never seen some of that stuff before. It's awesome. Who had these questions and was unsatisfied with some of the answers.
I don't know if it completely works or not, but I've been trying to use my own life more in an attempt to be more human like that, and so we'll see. Anyway,
nothing more human than having to tell people, by the way, I'm human. Like, that's just what a human would say.
Right. Where do we come from? Why are we here? What makes us special? And what do we do now? What should we do now? Those are the questions. If we could come up with an algorithm that, given a situation, would answer those things, then I think a lot of people would want to know that, especially if it was like systematic and it wasn't cheaty and it wasn't like you'll understand when you're older, all that kind of thing. So where do we go from here?
Okay, I wasn't sure if you were winding up or if you were waiting. Sorry about that. So, and we have, just so everybody knows, we have video, so we can see each other, and that somehow even that wasn't working. So yeah, fantastic. So as you structured it, there are basically two existing answers, and then your answer, which kind of draws on both of them in different ways. Yeah. So just to kind of jump to the punchline a little bit, there's kind of the software answer and the hardware answer, and then the computing answer, which of course computing always involves both hardware and software. So what's the software answer? Like who even has such a thing?
Who even has such a thing? Yeah. Well, so this wasn't even really completely clear to me until I started making up the slides for the talk and trying to figure out how I was going to do it. I mean, to me, as a scientist, the scientific theory of the universe, of particles, of all of that stuff that, says, it's all differential equations except for quantum, which is something else. And so on.
Negative probabilities, imaginary probabilities.
Yeah, imaginary probabilities. So that always, that I could get behind. On the other hand, there was, religion and faith and philosophy and all that stuff that to me seemed like not really relevant, because if it didn't explain protons and levers and so forth, then what good was it? And so I tended to push that away. But then as I started to get to this idea, that the key, the center of the whole thing is that you and I and everybody who's listening to this can be viewed as many possible things. We are beautiful little fountains of energy pods, and we are meat machines, and we are problem-solving devices. All of those things. We are all of those things simultaneously. There is not one thing that we are. But among all of those things that we are, one of the things we are is a programmable machine, not just a fixed rigid machine, but a programmable machine. And that means there are these two pieces. There's the hardware, the stuff that can't really change, but that has the ability to do work, the ability to do physical work. It has energy, it can move things and so on. And then it's got this software, which is much lighter, smaller. It's also physical. It takes up space in memory and in capacitors, in magnetic tape, whatever it is. While a piece of code is in some physical place, no other piece of code can be there. It's just as physical, but it's very light. It's very tiny. It's easy to change, at least if you're a programmable machine. I mean, you could have a machine that isn't programmable or is only programmable by tearing it apart and reassembling it. So then you kind of get into a degenerate case. Is that really a programmable machine or just a different machine that was made out of another one? That kind of thing. But there it is. And so then it was, geez, all of that stuff about, I think, therefore I am, why am I here? What is this feeling of first person consciousness I have inside me? What does it mean to have free will? All of that stuff. I understood that we were talking not about the physical universe, but we're talking about the code. We're talking about the software that we run. And the software that we run absolutely has a concept of like I, for example. And that concept has physical entailments. When I say I, it means this body. It means, and it doesn't mean a piece of random crap 100 miles away. So that was it. That's where it comes down. And that's why it's got two sides to it, and why we have to understand both the ideas of software, and we have to understand the ideas of hardware, and we have to understand how they fit together. And that's the theory of everything. That's the answer to everything. That's the claim.
So okay, I'm not seeing that yet, but let me work up to it a little more slowly. So when you talk about sort of hardware and software as being these two different things, and maybe like that religion and philosophy has dealt a lot with the software side, and that the physics and chemistry, the physical scientists have dealt very much with the hardware side, and neither of them is wrong necessarily, but they're not complete without the other. It reminds me very much of Stephen Jay Gould's notion of non-overlapping magisteria. Did you know that?
I remember that phrase, but unpack it again for me.
Well, so I think he brought it up mainly because he was frustrated with all the. No, Stephen Jay Gould was an evolutionary biologist who wrote a whole lot of books about and so he was not cool with the idea that religious people were attacking evolution in particular, right? So the evolutionary biologists have had to deal with this connection between those two different worlds, and his resolution, such as it was to say, you know what, it's okay, like we're talking about this thing, you guys are talking about that thing, you can talk about what you want, just don't talk about our thing, and we won't talk about your thing, right? The sciences shouldn't talk about morality and all those sort of things that make us human in that software sense. And the religious people need to stay out of the science and not make claims about what's happening and what's the prime mover, what is making things happen in the physical world. And so his goal was, we're just going to put up a wall between them, and it's like, now we're cool, right? It's like a two-state solution, as it were.
Good fences, exactly, make good neighbors. So non-overlapping magisteria, the majesty of science, the majesty of religion. They are focused on different things, and as long as they don't poach on each other, everything would be
we can all just get along. We can be good neighbors, right?
Yeah,
and I feel like you're almost there, but you also really appreciate the fact that you said it just a minute ago, that software is physical, right?
Yes.
It's not purely living in idea space.
It's Platonic. No.
And I want to say that that's kind of an important part of your story. I wonder if you could elaborate on that a little bit, because I think it's really like,
that's great.
I studied computer science. You studied computer science. Like it was very much presented in the form of, this is just pure idea space, and nobody had to say it out loud because it was just so obvious. It was just in everything that we were doing, and I remember I apologize if I've said this on the show before, but it was meaningful to me. The week of graduation, my friend Chris Metcalf walked me to where the computer was. Now I've been using the computer for 4 freaking years, of very long nights.
Undergraduate.
Yes, I was graduating as an undergrad. And he took me to the computer room, and he said, that's the computer that you've been like communicating with all this time. And my jaw dropped. I'm like, wait, it's a thing that lives in space. It's matter. It has weight. It has color. It's like scuffed up. Like that it just totally blew my mind. And I never wanted to think about it ever again.
Right. Well, and I certainly feel like, we have a lot of us in academia and technical stuff. We have a certain kind of brain damage from learning mathematics, where they told us that a point has no dimension, and a line has no width, and a plane has no thickness, like that. And that's fine for living in the land of math, where it's all just defined stuff. There's no real reality to it ever. The problem is when there's no reality to it ever, is it can't do anything. Mathematics is passive, it's static, and it only can get manipulated if there is a machine to manipulate it, which traditionally has been people's brains are the ones that manipulate math, the ones who understand what F equals ma means, and therefore you could make these transformations on it, not those transformations. And math was great, and it was fine because we could ignore the fact that people were doing all the work because we were us. We didn't have to think about it. We took ourselves for granted. But the day that we could make physical machinery, like an adding machine that you could turn a crank and chunk 6 + 9 is 15, now mathematics was being embodied by something other than us. And now mathematics was being transformed in a sequential step-by-step process by something other than us. And at that point, the only way that could happen is if the mathematics was physically embodied in a machine by the wheels from 0 to 9 being in a certain position, and you pull a lever and it cranks and pushes them and so on. It does whatever it is. And that ends up being in a one-to-one correspondence with the abstract Platonic addition operation as long as nothing breaks, like that. And so to me, it was certainly a big aha. I certainly at some point was thinking about software is not real, and thinking about the idea of cyberspace as another example, as something that wasn't real. That cyberspace was like Platonic B-hood space. It's just idea space. But it's not. It has to be somewhere. And that's when your friend Chris took you to see the machine. That's what fucking cyberspace looks like, buddy. Don't you forget it. Like that. No, I want to forget it.
Fighting and clawing against it, fighting against it. So we clearly lose something, but it's a model, right? Like
yes.
The idea that it's in pure idea space is a model, and all models are wrong. But what do we lose by allowing ourselves to think of it that way? And by trying to get it back, do we lose something else? Do we lose the ability to actually have these big ideas that then connect to each other in abstract space?
Well, my feeling is, because of like this hardware software distinction, that even though they're both physics, even though the big heavy copper wire with the power coming in to power the machine and the tiniest little capacitor that's holding a 0 or a 1 bit have extremely different properties, they're both physical. They're both part of a machine. And so, and again, and this is part of what gets talked about in the video. So the laws of physics say we don't need any distinction between hardware and software because it's all just physics.
It's all just okay.
Like that. It's electrons. We can just solve the wave equation for it all and go along with it. And my reply to that is, in the abstract, theory is good in theory, but theory is not good in practice. And that's the problem. So yes, we could pretend that we could just use the wave equation, we could just use the laws of physics, and we could solve everything. But number one, that's not true, because we have combinatorial explosions all over the place telling us there's way too many possibilities that we'll never be able to evaluate. And number two, there's chaotic systems where if we make any error in understanding it, we won't be able to predict where it's going to happen later on because the error will grow and grow. And as a result, even if we tried to solve the wave equation, what we would end up doing, I claim, is we would end up saying, well, there's this part of the thing that's really quite rigid. We could make a model of this transistor and this copper wire and so on and so forth. That would be a theory that would hang together pretty well, regardless of what's going in on those zeros and ones there. Regardless of whether that's a positive charge or a negative charge in that spot, that spot, that spot, and that spot. And then we would publish a paper in Nature Physics D, saying, we've got this great ansatz, this great approximation that we've discovered to how analyze these systems. And what, in fact, we would have done at that point is invent the hardware-software distinction to make it more practical to understand what a whole system is doing like that. Because hardware has very different possibilities and limitations and reliabilities, and software has very different possibilities as well, like that. And so my claim is that since we cannot, for computational reasons, actually prove everything from first principles, we can never get that answer. So to me, it's kind of a waste of time to talk about, is the universe deterministic, or is it possible in principle to figure out everything? So we have no free will because it's all been set inside, all of that stuff. I understand why we need to boggle our minds with it at some point as we grow in our computational capacity and understanding. But I also think we need to then put childish things aside and say, it doesn't matter because we're still not going to be able to use that fact to do anything. And therefore, we're going to be stuck making these assumptions and heuristics and so forth. And sooner or later, we're going to have to say, what are some good assumptions to make? We understand they're not perfect. We understand, the model idea. And that's where it is. And my feeling is that hardware and software as one of those rough and ready sets of assumptions that's worth embracing and saying, yeah, it's going to be wrong in various places. And we'll just know that going in. There's going to be bits that are kind of like hardware, kind of like software. There's going to be things where, if you run this particular piece of software, the hardware gradually changes. Like, learning how to play tennis, by doing this software exercise. And then all of a sudden you have big tennis muscles, that's violating the official rules of hardware and software. But nonetheless, it allows us to be a rough and ready, compact expression of a tremendous amount of stuff that's relevant to people.
So, okay, so what I'm hearing is that you're arguing for the sort of notion of you want to carve nature at its joints, and the hardware software boundary is a really very good joint.
That's exactly right. Because
and
even though they're all physics, the one thing that is tiny and light and changeable, the other one that's big, massive, and energetic, have just in practical terms have very different affordances, very different consequences.
But you want us to remember that abstractions leak, right? That there's a boundary, it's a nice boundary, but you get close to the boundary and there's weird things that happen where you have to pay attention to the fact that that they're really connected. They're not isolatable.
Right. That they are all physics, and that physics is not going to be able to help us out either with those boundary cases, because again, it's all going to be way too complicated for building up from first principles to solve things. But we'd be able to say the choice is on us. It's not that the universe is forcing us to say there's hardware and software. That's never the case. What it is we are coders. We are designers of code. And one of the things is the hardware software concept is a framework. It's an application program interface. It's an API. It's an API. It's a way of structuring code like that. And if we know it, if we share the hardware software API, then we can express stuff in those terms, and we can make compact code transmissions that will have a good shot at doing what we sort of meant them to do. And that's what it's all about. And the thing that drives me crazy is people act like they're talking about the truth of the universe. Neurons are not hardware. Pulses spikes are not bits, and so forth. They are whatever. And the response is, well, yeah, sure. Obviously, the code, the universe is what it is, but the code we have to choose. All of the code we have to choose. The words we use, do we call it neurons? Do we call it transistors? That's all on us. The universe cannot tell us we have to call it foo or bar or blech.
Yeah, I like that very much, because it brings back into focus this sort of idea, as you say, that it's a model or it's an imposition that we're making on the world to make it more tractable, right? Like, it's absolutely critical that we do it, but it doesn't mean that it's there. It doesn't mean that it exists. It means that when we put this structure on top of it, it gives us power to, for example, predict future states of the world or some properties of future states of the world that we can then experience.
Right.
So that makes a lot of sense to me.
And so people spend a tremendous amount of time arguing about what is. And what they really mean by that is, if I accepted your way of expressing the code and I put that into my computer in my head and crank the prediction engine, it says blah, blah would happen. And that seems ridiculous. Whereas if you put this piece of code in, which is my suggestion, then turn the crank, it would lead to this other thing, which makes a lot of sense. And so therefore I say X is true and Y is false. But really, it's all just about debugging the code. None of it is directly about the universe out there. The universe out there, we cannot say squat about. It's all about arguing about the code. Express it this way, express it that way. And when we use the word is, that's what we're trying to do. We're arguing about the dictionary entries in the code book that we are operating on.
Code and code book. Very nice. So refactoring comes to mind when you talk like that, because I do feel like when you have two software engineers kind of figuring out how to structure their system, you get these long debates about refactoring. Like
Right.
what is it?
Yes.
How should we put? No. That can't be part of the API, right? That can't be part,
Yes.
because that's going to have these repercussions. It's going
That's
to
going to
screw
mess
everything
up
up.
this, and but yes.
Yeah. So what's nice about software though is that we get to make those decisions, and then it kind of is like the software structure that we pick is a software structure that becomes instantiated. Whereas
Yes.
when we're talking about the real physical universe, it's all wrong, right? Like it's just a heuristic for describing things. It doesn't make the universe have that structure. I can call that
But
thing outside my window a tree, and it gives me some affordances, some ability to think about it, but like
to
where the
refer
roots
to it,
end and where the ground starts, and whether that's grass, whether that's moss on the tree or that's part of the tree,
all vague.
we can all sort of debate that later.
Right. Uh, um, so I think if I followed what you're saying, that it's, I think it's a little more strict than that. So
Okay.
you were suggesting that when we actually make software, then it's real. Here it is. It's a file.exe or whatever the heck it is. Whereas when we're just describing things, the tree and so forth, it's not. But it is. The code is real in your brain. It's just as real as file.exe. It doesn't have the same affordances. We can't easily, readily make a copy of file.exe. We can make a copy of file.exe and send it to all of your contacts to infect them. But we can't do the same with your image of a tree. We don't have a way to pull it out. But it's just as physical. It's just as real. It just doesn't have as much objectivity like that. We can't. So we design computers so that we can copy the code with extremely high reliability. Then that's the whole digital brilliance, that if we make clearly separated levels, 0 and 1, and make sure that whatever physical implementation we use has a big gap between what counts as a 0 and what counts as a 1. So the chance of getting it wrong, we can make very, very low. That's what allows us to make the copies of all of this code that we cannot do, at least at present, with Michael's tree with the moss and the grass. But it doesn't mean the tree with the moss and the grass is any less real. It's in your head, just like code is in a CPU.
Okay, that made me have lots of interesting thoughts. So one thing was that when human beings design computers, I don't know if we give von Neumann credit for this or whoever we give credit for, but the sort of idea of the bits being these deterministic things, it's almost like we took what we wanted, what our minds want the world to be like, and then we made a world that was much more like that than the real world is. And now all these nasty border cases where we have to really pay attention to the fact that, okay, we don't really know, like they go mostly away. And we get to live in this pure, beautiful world. Like thinking of the software world as basically being an instantiation of our like deep human desires, as opposed to and just an engineering artifact, like a fork. Yeah. Like a fork is great. Like I use forks all the time to eat food, but the notion that we created that particular structure, that kind of computing structure, because it was what our hearts really wanted, right? It's the way that we would like to see the world. So we made a world that kind of acts that way. That was new to me. I hadn't thought about that before.
Well, I think so for sure. We made computers in the image of our mind, not in the image of our brain. Although the neural net folks were trying to do that, so it's been a two horses running down the track the whole time, one with the brain modelers and one with the mind modelers, like that. But I have to push back just a little that that all the problems go away. Yes, until you start sending code and giving amplification to code and putting code together with other code. And then you discover
the cracks in the
the
abstraction.
the cracks, also known as computer security, also
Right.
known as you cannot do this. And because and everybody who still is stuck in the land of deterministic execution is essentially going, nah, 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 I don't want
We
to
don't want
hear
to
it,
hear
I don't
it.
want to hear it, like that. And I understand that it's a huge drag, because the world of the mind, the perfect world of bits, is very beguiling
Right.
and
Seductive.
siren song.
Yeah.
And cybersecurity is the fucking rocks.
Right,
Uh,
because it turns
um,
it back into like physics and everything, and reality starts to matter again. And
exactly.
I viewed
And
this as
everybody has been ignoring the physics all along with la 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 la. I'm such a mathematician. I'm so abstract. I'm so theoretical. I don't do dirty my hands with actual voltages, and all that stuff. And then
okay.
someone
Well,
says,
that's
"Yeah, well, I will mess with voltages, and I will take all of your bitcoins." Ha ha ha. Like that. So yeah,
right.
absolutely.
Okay, that's super interesting. I another thought that I was having while you were talking was you must have read Foundation, right? We were talking about books earlier. That must have been a thing that
The
you read.
Asimov series,
Yeah. And the
with
notion of psychohistory, right? That
right.
you that like, huh, well, minds are physics, and physics, we can talk about the evolution of physics over a long period of time. So Asimov imagined, well, maybe we could just do that with like the software hardware combination, project this forward, and we can see where we're going as a species
Right.
into thousands of years into the future. Like, I find that not very compelling. Like, it seems to me that choices matter and the details matter, and the fact that it is software means that it becomes very difficult to predict en masse what's going to happen. But
Yeah.
like, how does this all fit together for you?
Well, I did read the Foundation series way back when. I haven't read it in decades.
It's a
Again,
TV series, so I haven't read it, but I'm watching the
uh,
TV series, which I'm told is completely different in every possible way. So
I
I'm
see.
utterly
Uh, uh,
uninformed about the actual books, but they
okay,
do
but
have
no, you got
psychohistory
the
and
concept.
Selden.
Yeah, you got the concept right. And uh, I guess if you're in the middle of it, I mean, there's a huge spoiler midway through the series that's important to the ideas here. So I don't know if you've gotten to it or not. So I'm going to let that go for the moment.
All right.
But so the idea that you could predict technological breakthroughs, that the mind body meld will be perfected in 2057, or whatever it is, and therefore blah 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 blah. That seems like the absolute quintessence of what won't happen,
Okay.
because
Yeah.
creativity is a significantly random process, that deciding to put different things together or put different colors together or making an accident and saying, oh, what about that? And so forth, is, as far as I can tell, by any stretch of the imagination, as long as we take the super determinists and say, yeah, 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 go stay in your rubber room, like that. Anybody who's in the real world is going to say that this is a stochastic process. This is a randomized process. You don't know when it's going to happen. And the amazing thing about a programmable machine is that, well, depending on how the code is done and how big the machine is and blah, 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 what a machine does, what a computer does, is it takes signals from some significant area, inputs, whatever it is, and it brings them all by reducing them into simpler forms and saying, I'm going to recode that whole thing and call it Michael, and I'm going to recode that whole thing and call it my monitor, and so forth, and bring them down so that we get a ton of information, extremely rich, high density encoding, which we can then do computations on. I could move Michael to my monitor, whatever it is. That if you multiplied that out to how many photons and protons does that mean you'd have to move to do that? It's billions, trillions, gazillions like that. But we managed to make this incredibly nonlinear computation by pulling all these bits together and then making a relatively simple nonlinearity, and then discharging it back out again. And how does that relate? What am I talking about?
So it seems like it's highly nonlinear, highly dependent
Right.
on random
Yes.
chance, but then amplified
Yes,
out.
there it
And this
is.
is why
There it is.
psychohistory is going to be a problem.
Exactly. And so there's the determinism laid on top of all of this stuff. And that would be fine. You can have random systems like thermodynamics. You can,
Right.
where there's an extremely well-defined temperature that you can get for this box of gas.
All of which is going pew, pew,
like
pew,
that,
random,
even though it's
random.
all completely random out the kazoo. But that's because the gas laws are very nearly linear. They're very low order. The things that are bouncing off each other affect only the things that are bouncing off each other, and so forth. And the chances of having a cascade that this thing bounced that thing just in the right way that caused it to bounce that thing and just are so vastly unlikely that you can easily ignore them for the life of the universe. But with a computer, with a program, we can pull all of these events together, make a change that we can do. It's because it's low enough so we can say, is X equal to 0? Then go one way, else go the other. But now we can amplify that. And the fact that we went one way or the other, I have to sneeze.
And I had to cough, but I actually muted myself.
If I could have found it, but I had to anyway.
There's too many buttons.
Well, I'm not on Zoom anymore because I went to see what the questions were at the.
That was my fault too. Yeah, got
it. And so, where the hell were we?
I'm going to cut off.
So unlike the gas law, we can take a decision. We can take a decision and we can say, wow, that's really good. I hadn't thought of that. I'm going to write that down. I'm going to tell other people. I'm going to build a model of it. I am going to, and so that you get, and that's why focusing on the gain, focusing on the amplification, focusing on the acts of code transmission from A to B is so critical. And that's why psychohistory and the idea of being able to average out over a thermodynamic system is so silly, like that. And so, the foundation, I super enjoyed it. I read tons of Asimov as a kid, but he was always actually surprisingly weak on computers. His science fiction futures, they have robots sometimes, but the idea of ship's computers and all that kind of stuff, not so much like that. I don't know what to make of that, but there you go.
So, okay. And that also reminds me a bit of this notion of free will. So I got to tell a quick story because I'm a whiny little brat. So there's all the big news outlets, New York Times and LA Times and all these other ones are talking about a new book that came out about free will, where a neuroscientist says there's no such thing as free will. And first of all, I'm thinking, okay, first we all knew that. And second of all, if they want to talk about a book, talk about my book. So I don't know if you've been tracking this at all, or if you've heard about this story, but
who are we talking about?
A neuroscientist who wrote about free will, who has a beard.
But not Sam Harris.
No.
Free will neuroscience new book.
I feel like new book is not a great search term.
Philosophers and neuroscientists.
Robert Sapolsky.
I've heard that name.
Term, yeah, he's pretty famous. That may be part of the issue, is that newspapers want to write about people that are already famous, and I'm not one of those people. But the book is called Determined, right?
A Science of Life Without Free Will.
There you go. So my reaction was basically yeah, all right. If you think about free will from a physics perspective, physics is just physics, and there's no will anywhere, and of course there's no free will. But as a kind of a software construct, as a way of organizing our thinking about how things work in the world, it's incredibly powerful and useful to think, okay, what that critter just did is made a decision to do this instead of that. Now, sure, in reality, that decision maybe was made because of the life history of that particular critter, person, animal, computer, whatever it happens to be. Yep. But that's not helpful for me as an outside observer, because computational complexity is real, right? Mm-hmm. The notion that we could take all those details and then follow the implications of all of them to the point where I can actually say, okay, and then he's going to do that. Look, he did it. Is just not helpful.
Yeah. And This makes me think of a related thing. So I'm just looking at the table of contents here of this determined book, and in chapter 1 is turtles all the way down, sure. And
See, my book has turtles all the way down in it, except I made a really good joke about it.
Yeah, well, I use turtles repeatedly in the Theory of Everything video. It was one of the where did we come from, what's it all about answers. So one of the things that gets me is hopefully I'll remember how to get back to where we're going here. But the distinction I want to talk about is literal versus metaphor. And people, because when I start talking about this stuff, we are coders and science is a code base and all that sort of stuff. After people, manage to take their jaws off the floor and they say something like, "Are you talking about metaphor?"
Because that's a way out of like not accepting
exactly
what you're saying at full force. It's like, well, sure, it's suggestive of that.
It's like that. It's not real. It's not literally true. As if there is something that is literally true. And that's the fallacy, right? That language is all metaphor. Language is all code. And, the idea of literal as meaning, this is the correct description of the universe and this other thing is mere metaphor. Is, it's the incumbent supremacy way of framing things. Say someone's coming from really what literal means. And linguists know this. And I was reading some papers.
So teenagers have decided that literal means figurative.
Yeah, sure.
But anyway.
Well, it's because they're just teenagers, so they're being douchebags.
It's taking over everybody now. Everybody.
Yeah, I know.
We're all douchebags at the end of the day.
And that what literal actually means in the best sense of it before it got ruined, just like Beg the Question got ruined.
That was exactly the example I was thinking of. I was going to try to work that in because it boils my blood every time. Otherwise, smart people are using this phrase and they need to stop.
Well, I used to feel like that. I think the ship has sailed now. I say raise the question.
Raise the question. It raises the question.
Yeah, it's so, like a quarter of a syllable slower than begs the question. But it leaves room for correctness. So it raises the question. And now we're
literal. You were telling me what literal
there we
means.
are. Yes, thank you. And what literal really means is established convention. It means the use of this particular term to mean dirt and not to mean ground or whatever it is. And so we say that is literally dirt. What it means is I am referring to the established widespread convention. And that's fine. I'm great with that. But then metaphor is just, a less used convention or perhaps a idiosyncratic one. I don't care, whatever, like that. But as long as we understand that the only reason the literal is privileged is because it's conventionally widely used, not because it somehow magically exists out in the universe and this metaphorical stuff doesn't exist.
Right. Yeah.
So that means then it's okay, because then once again, we are still just being coders, developing, arguing about refactorings, that it would be better if we thought about physics not as being a complete, unified single equation of everything, but if we thought about it as being the best mathematization of physical consequences that we can, assuming things like Newtonian notions of objects and of mass and force and energy and all that stuff, all of which are just terms. They're all approximate. None of that stuff is physically real. They're all the way we do it. And then we can accept all that and yet let go of the pompousness of physics, that the laws of physics they are true, and all this other stuff is crap.
Yeah, so I think it's really hard for people to think that way because
yes.
So I am what it brings to mind for me an episode of Star Trek Next Generation called Darmok, where basically there's a language,
the metaphor,
metaphor. It's a metaphor language, and so they have to learn how to communicate in these metaphors. And then I'm watching this, I'm thinking, all of language is a metaphor.
Yeah,
So like,
exactly.
how did they manage to translate the literal words? Because the Darmok language would say things
Yeah.
like Darmok and Jalad at Tanagra, as if
Yes.
somehow Darmok, which refers to a person, Jalad is a
Uh-huh.
person, and is a
And
conjunction.
the word
Like
at means something.
all those things are somehow literal,
Yes.
but then
Yeah.
that phrase as a whole refers to something else, and you have to learn what that is.
Yes.
No.
Yes.
I mean, it's a beautiful episode, and it gets you thinking, but it gets you maybe thinking a little bit in the wrong direction.
Yeah, and that episode is one of the episodes that I most love to hate, because of exactly what you're
All
talking
right.
about. Yeah, and I imagine there could have been an episode that. Well, if they'd done that episode honestly, what I would think of as honestly, it would have been more like that movie with the first contact with the aliens, with the circles and all that stuff, where it's like whole totally different.
I think Arrival is the name of the movie.
Arrival, yeah, sounds right. And trying to figure out what is a word, what is a concept, that kind of thing is all right. But and so the Darmok and Gelato and Sorbonne, like that is.
Now I want ice cream.
Like that.
All right,
always drives me crazy.
Okay, all right. So we sort of deserve each other, I guess, if we're both annoyed by this. First of all, the whole begs the question thing, and second of all, the whole Darmok thing, which everyone else seems fine with for whatever it's worth.
Yeah.
All right.
Well, and I try to tell myself that maybe that at least gets people thinking about the meaning of language, and that even if it mostly gets them thinking slightly wrong stuff, like there is a real meaning, and the whole Darmok and Gelato is really the entire thing is one word. It could just be like that, and that means
I'm lost or angry or whatever.
Yeah, or I'm gonna come back from defeat or whatever it is, like that. Right. So yeah.
All right, so we totally agree on these issues. Here's an issue where I think maybe we agree a bit less. So I was very happy in the video where you were like on board with computational complexity, sort of the notion that really computing through all these different combinations, unless you have a systematic way to do it, it blows up, and it just, that's not going to happen. And so
you're never going to know you have the best answer. Yeah,
it's almost like a physics of like, that's a really heavy rock. If you're going to lift that rock, it's going to require a lot of energy in some form or another. If you're going to
find the best of this thing,
sort this list, right. So that was great, but then you really harshed on computability, which to me, there's really the same idea, just applied at different levels. And you hated on it so hard. You even had a separate clip of just you hating on that.
Yes.
That was the first video that you've ever made where I wanted to click a thumbs down just to signal like, no, I do not accept this video.
Okay,
so maybe we need to hash this out a little bit.
Now I must break you.
Okay, we're off to a really good start.
Go ahead. So what is good about computability that isn't already covered by computational complexity?
Okay, I didn't want to go that way.
Okay, well then you take any way you like. I wanted to go
from the thing that you hate on with regard to computability is this notion of asymptopia, right? Like this is something that's true in the infinite extent, and that's not real. Like we can never get to infinity anyway.
It's non-constructive.
It's non-constructive.
It doesn't tell us how to build a machine. I mean, the universal part is the universal computation idea. That is constructive. Again, is if you can assume deterministic execution,
which you can in small doses, right?
Exactly.
As long as you don't try to reach infinity, you have this nice little world where things make sense and you can do things. Right?
As long as you pick the space-time window up front before you design and build the machine, then you can have deterministic execution like that. It may cost a ton, but you have to pick the size first, and then size the probabilities for how many gates and how many hours you need the computation to run.
Well, okay, but so when we're doing computational complexity analysis, we also have to use infinity there, right? Maybe we're using it in a way that doesn't bother you as much, but it is still in there. that a
Like
lot
what?
of these big O analyses are only true in the limit, right? They're like
Yeah.
on your way there, they can be arbitrarily far, like I don't know.
Sure.
I mean, some of this
Sure.
you could probably hate some of these complexity results, but things like, well, we can make a universal algorithm that can sort in the minimum possible sorting time. All it has to do is list all the possible Turing machines in order, and then run each of them for a little while each. And so then what you end up getting is until an answer comes out, and then you stop the whole thing. So you can analyze that and show that the time that it takes to complete the task is the minimum possible asymptotic time to complete the task. So if it's
Right.
sorting, it'll run in n log n, right?
Right. Yes.
Without you having to make an n log n
Times a
algorithm,
gajillion.
plus this giant constant, which overwhelms
Multiplying.
this. Yeah,
Yes.
right.
Sure.
It's either a multiplicative constant or an additive constant. But the fact of the matter is, there's these
Yeah.
giant constants that render the whole thing kind
Sure.
of not helpful.
Sure. Well, and my reaction to that is I have problems with computational complexity too.
I would think you would,
But I
yeah.
was trying. I was
All right,
trying
all
to
right.
to come as far as I could.
That's fair. And it warmed my heart to see you come as far as you went. But somehow
Okay.
I think it then held out the promise of you going farther, and then you stopped, and then I got
Well,
sad.
no, I mean, because I think computability does harm. I think computability sends people down blind alleys. I really think, I mean, characterizing it as a dead end I think is spot on. I think it's charitable. I mean,
So first of all, there's not that many people spending a lot of time thinking about it. So I don't know why it bothers you that anybody's thinking about it.
well, Wolfram for one.
Oh, does he do computability things? So maybe that's
A new kind of science is all based on superdeterminism, universal computation, and all of that crap. And I think that's set the
I
field
see.
back.
So you
to the
might have been
degree-
fighting against a slightly different
villain.
instantiation of that than I was focused on. Because
Right.
I find it really useful, like to think about a sorting algorithm that runs in n log n. Like it actually gives you insights about what's
Sure.
possible and what's not possible. And you'd
Sure.
be like, well, I want it to be
Computational
linear.
complexity.
Like, well,
Sure.
you could want that. But
Sure.
and
But
the notion of
undecidability doesn't do that. Halting problem doesn't do that.
But it answers a question that is a reasonable question, which is it possible to make a program that would do this and terminate in finite time?
Right.
And the answer
is no. Yes. Great. Now what?
Okay. So that's
the dead end part of it.
I see. And do we count? So some people group together things like lower bounds, things that say like, well, you can't like proving that P does not equal NP. That would be a computational, or I guess maybe it would be computational complexity and
Sure.
not computability.
Sure. Like that. I mean, I don't like non-constructive proofs. I am essentially an intuitionist in the logical frameworks, and because, as far as I'm concerned, if one proves something without providing a path to an implementation, then you're just fobbing the work off on somebody else. So you're just trying to take the credit for something without actually doing the work to make it real, to make it
But
useful.
negative, like lower bound results, negative results, or
That you
I don't
can't
know.
do it faster than this.
Yeah, they can't be constructive because they actually have to rule out all possible answers.
Yes. And, and again, as long as people don't get too cosmic about a lower bound,
Okay.
that the theory of everything, the new kind of science,
Right.
like that.
Well, some of our threads actually have been brought together. Like people have said things like, there's no free will. Wait, there is free will. There is free will because of
You can't
computability.
compute it. Right.
Yeah, yeah.
No, well,
That's like they relate it to the halting problem specifically.
Okay. Well,
But maybe you wouldn't go that far. Yeah,
I certainly wouldn't go that way at all.
because you can get a lot of the juice out of that by just with the computational complexity. Just saying,
Exactly.
well, you could compute it in principle, but it can't be done in practice because it would take forever.
Right. So we don't need computability to say what free will could
I
mean.
see.
Like that.
Okay. All
And
right.
yeah.
No, that was really helpful because I don't think I got all the context around that, and it was is making me sad. But this
Well,
is, at least
and
I understand where you're coming from.
yeah, I did feel like that there is something not notch that needed to be brought down a little bit, and that's why I ended up with a drive by. You know, what you end up with is a dead end kind of science, like that.
Yeah. All right.
That's
Gotcha.
it. That's in there. So,
All right. Well, so we've
we're
maybe we
toward the
should
end of
kind
our
of land
time.
the plane. And I was thinking maybe as a final question,
Go.
you could help answer the four questions.
Ah, all right.
Why is this night different from all other nights? Why do we eat reclining? Okay, no, those are different four questions. But these four questions were: why are we here? Where did I come from? Why am I here? What makes us specialists? Oh, it got
What makes
spell
us
corrected.
special?
Yeah, I know it was a spell correct. And what do we do now? So,
Right.
do you have answers to
Sure,
these?
sure. Well, I mean, I can quote the answers more or less from the video,
Okay.
and
Where did I
where did
come
we
from?
where did we come from? We came from an unbroken, flawless chain of successful ancestors all the way back to the origin of life.
All right, so that's like
That's where we came
evolution and
from.
whatever brought life into. But like, okay, all right.
No, no.
Why are we? Why are we smart? Or what is
Uh,
it?
uh,
What does it mean that we're smart?
uh,
That wasn't one of your
um,
questions, but that, like, to me,
well,
like, how does
it's
life
kind
get started and how does intelligence? Where does intelligence come from? Those are like my two favorites.
well, so if we take this idea that there's this triumvirate of life, computation, and meaning that co-define each other, like that, which is another part of the video, then that would argue that there is like the proto version of intelligence all the way back at the proto version of life and the proto version of meaning. It's not like there was life first and then intelligence came later,
Mm.
like that. And so we came from an unbroken chain of ancestors to the origin of life, which to me feels very spiritual. To
Mm.
me, it feels like, you know, you should revere your ancestors. You should literally honor your ancestors, no matter how one's life is going right now. That remains true.
We
That
wouldn't
is
be here if not for them.
not for the unbroken chain of successful
All of
ancestors
them.
all the way back to the origin of life. Like that.
So
Number
can I
two,
honor them just by existing? Like, isn't that enough?
well, it depends. Are you
Okay.
hung up? Are you bummed out? Are you depressed? If everything is fine, everything is fine. But
Mm.
the big questions matter the most when we're hung up, when we're stuck, when we're saying, I don't get it. What is the point? Why am I living?
Nice.
That's what we need to deal with. That's where we need to get people unhung up. So that they can find they can honor their ancestors in a more active and valuable way.
Okay, so it's a really
Like
nice
that.
pitch because it really does attach to the meaning that we have as human beings about all this stuff, and it kind of works for the whole physics of it too. Like, as far as science is concerned, that's an apt description.
Yeah, I don't think all of this stuff is going to be compatible with other notions of physics, except where physics has just gone too far, where physics has made a mistake, or physicists have made a mistake, and so that's all great, but we've already agreed that merely being true in some sense doesn't mean that's the code that we want to ship. That there's many ways to describe true things that may have different affordances, different advantages, different bugs, different failure modes, and so on. So it may be that even though you could claim it's all protons in the Big Bang, that you'd be better off claiming it's an unbroken chain of ancestors back to the origin of life. That's the claim.
All
That
right.
this is the software. These are the answers that if we choose them, it will do well for us. It will do well for us individually and for all of us together. That's the idea.
All right.
Why are
So
we here?
yeah.
Number two, we're here to preserve our patterns, whatever we conceive of them to be. Since that's the whole basis of life, is to preserve your pattern. And it goes from the most crass physical sense of keeping away the mountain lions and finding enough to eat, all the way up to I identify as for the rule of law and democracy, and I want to preserve those patterns as well. That's all part of it. Why are we here?
So that's really interesting because of the, I want to say, choice that people get to make in terms of what to relate to in terms of the pattern. So in particular, like when you said I want to preserve my pattern, the first thing I thought of is the kind of, I want to say, very icky people who go and like rob the sperm bank and replace all of the sperm samples with their own sperm, right? It's like,
Yeah.
yes, I will preserve my pattern.
Yeah. Yeah. Yeah.
And that is like, that's legitimate with respect to, if that's what you think your pattern is, you're kind of
That's
doing
right.
that.
That's right.
But
Uh,
yuck.
uh,
But second of all, but it doesn't require that, right? You can be preserving your pattern in other ways. Your
Absolutely.
ideas could be out there. You could be taking care of life, humanity. You say democracy, just
Rule of law,
earthness.
all of this
Yeah,
stuff,
whatever
whatever it is.
you
The
can.
planet. How about the planet?
How about
That
the
would be a
planet?
good thing to
That would
identify
be like,
with.
even if that's not where you're identifying, it still might be good to think about the planet, even if you're just thinking about the sperm bank.
Yeah. So absolutely.
Okay.
And since we are programmable machines, the patterns, our patterns, what we conceive them to be, are themselves programmable and subject to change by existing in the world and receiving code transmissions from others, intentionally or not, and making code transmissions, creating new code of our own, and so forth. And so that's what it is. There's no claim that the patterns we conceive them to be are fixed or they are handed to us from the outside. It's just, that's why we're here. We're here to say, I think that's cool. I want to preserve that. How can I help?
So, and is that unique to humanity in some sense? Like, I do feel like rocks that are rocks or whatever, like they're not preserving their pattern by choosing what aspect of their pattern to that they care about and preserving
Right.
that.
Right.
Like, is
It's not,
that
it's,
the ability to frame things and say, okay, I'm going to identify with this attribute.
so I would say there's quite a bit of room between rocks and people, like all the rest of living systems count, like that. So cats and planaria and rotifer, microscopic creatures and
All
so
right, so
forth.
cats. Let's do cats for a moment. You know a lot about cats. Like,
Uh,
so are how much are cats getting to choose which aspect of their pattern to preserve?
well, I mean, I believe that my cats, our cats here in the house, um, if it looks like we're in trouble,
Mm,
they have certain concerns. Now, it
okay.
may be that they're just waiting to see if they can now eat our faces because we're dead, but it doesn't seem that way, like that. It seems
They have legitimate, like you've become part of their pattern, is what you're saying,
exactly,
and that
exactly.
we got to love that. You got to respect that.
Yeah, and anything where like you've got the ants that cultivate the fungus, they cut the leaves and they take it down so they cultivate the fungus.
I think they're
That
aphids,
they're preserving the fungus patterns
right?
because that's in the larger thing. So everywhere that is a property of life, and so not humanity,
Mm,
like that. And so rock is a degenerate case because it doesn't seem to do work to preserve its
preserve its
pattern.
pattern.
Yeah, it just sits there and tries to weather as slowly as possible, like that.
The classic hard case. All right, so what makes us specialists?
What makes us special? And again, this was another one which really wasn't clear to me until I was making up the talk. Is it's the code, it's the code base, it's the code that we run that makes us special. And yes, there might be little genetic properties or something, cultural properties, physical properties that we have that make us different than bonobos or chimpanzees or whatever it is, related stuff, even though we share 99.99999% of the genome and all of that kind of thing. What makes us special is the fact that we have this gigantic code base. We have this cultural inheritance that we teach to our kids, that gets them booted far enough up that they can now start getting code from other places, not just the parents, from books and other people and movies and all the rest. And then they turn around and contribute to that code base by making their social media posts and writing their books and making their movies and doing whatever it is and keeping the code base alive and evolving. That's what makes us special.
That's really fun because like sometimes I watch, I guess, historical reenactments and I think like are we that is that us or is that not us? And the answer is yes and no, right? So it's they don't have the
Yes.
same code base. They don't have the same uh
Yes.
cultural expectations or whatever it happens to be. And so, is it okay for them to do weird, racist, or dangerous things? Well, it's not. It is. It
It
was
was
what it
it,
was,
it
but
was
it
it
would
was
not be
never
okay
good.
now.
It was never good, but it was what it was. And
And it's not okay now. And why is
well,
it not okay
but
now? Well, partly because this is the code base that we've got.
because
That.
absolutely, and the code base is under continuous evolution, continuous modification. Put it that way.
Mm,
It's not so clear that it's a classic evolutionary situation. But yes, absolutely, and the fact that our code base is so big, so rich, and so much more than just what we can get from our parents, makes it so obvious that in fact is our actual specialty. That's
mm,
the reason that things can look so different to us, like that. And it says that if you took a baby, and hijacked it to another planet with no parents and just gave it enough, plug in the wall to survive, that kid would have a lot of trouble. Would have a tremendous amount of trouble. Would have to, reinvent physics and so on and so forth. There's like a quote from Feynman, where he says, the most important thing is to have one fact to go, if society was going to collapse
mm.
and be only able to pass one fact along, it should be everything is made of atoms. That's the kind of idea that would get you the most bang for your buck if you were starting to boot the code base from scratch, like that. Again, assuming you could figure out what the hell an atom means and everything means and so on and so forth.
Mm,
What makes
mm.
us special? It's the code.
Not
And
that
find
so you could mean two different things when you say it that way. You could mean
Yeah.
the fact that we run code, the fact that we're programmable
Well,
machines,
and yeah,
or like this specific code actually kind of makes us special.
yeah. And usually what I try to emphasize is what makes us special. It's our code base, yeah, as opposed to just saying it's the code,
Okay.
like that. So the code base is special, not because it's the best code base of this size that
Mm.
could be created, but because it is a code base of this size, and there's a tremendous amount within it that allows us to make predictive, useful predictions about how this is going to work, how that's going to work, and so on, so that we can help preserve our patterns.
And to you, code bases. So okay. So does ChatGPT have our code base?
ChatGPT, to say have is a
Yeah.
little bit wrong, because we don't have it either. We are a projection of our code base, and the fact that we are running is our contribution. We're preserving the code that's in our head while we're alive, and while we're running it and deciding what it is and so on and so forth. And ChatGPT, while it's running, has similar features. It produces behavior according to statistics that it got from our code base and so on and so forth.
Or at least our
So
written instantiation of some
exactly,
aspect of our code base.
whatever it happened to be, the, the,
Yeah.
the code that it is. And it's easy to believe, from how well it works these days in its own stupid way, that there's a tremendous amount that is implicit in text and images and so on and so
And
forth.
sometimes explicit. Like a lot of it is actually spelled out.
Yeah, absolutely. And whatever. That's
Okay.
another topic.
All right. So, and when you just one thing that I just want to I want to put a pin in. This is a phrase that
As they
you and
say.
I discussed right before the recording.
Right.
Is code base of a size is a thing that I hadn't really thought about. Like to the extent that we think of our global mutual identity is this code base, and the code base is physically instantiated in each of our
Yes.
heads in some way.
And in libraries and so on and so forth.
Yeah, but okay, but what we can carry around with us is
Yes.
limited
Yes.
by the fact that we only have so many neurons. And
Yes.
so does that puts constraints on the code base in various ways, right?
Absolutely, yes. And that's why there, among all the other needs that us code developers have to work on, we need to come up with compact ways
Mm.
to represent this stuff, compact ways into material that will hopefully not lead us wrong, or will lead us right more than it will lead us wrong, like that. So yeah, it's not simply saying all we need is the 9 billion names of God to be written down in a thing. We also need the frickin' jingle that happens in the 15-second spot.
Yeah.
We are coders. We're so great. We ship code. We're so great. We are coders, coders, coders. There it is.
Right. To make it
And
sticky enough that it actually
to
stays
make
around
it
and
exactly so we maintain the code base by making it
maintain the
sticky,
code
by
base.
having it in all levels,
Because
like
as any
that.
software developer knows, there's programming, which is hard, and then there's maintenance, which is harder.
That's right. There's distribution and maintenance,
Mm.
and coders tend to forget about distribution and maintenance. They learn about maintenance
Right.
quicker than they learn about distribution,
Yeah.
like that. But that's the amazing thing in the social media these days. We can all shout into the void and be
Mm.
completely ignored, and we've now
Oh,
learned that.
I see you. I see you noticed my book.
Exactly. Before we get to middle school,
Right.
like that. Whereas we used to be able to think, oh, when I finish my masterpiece, like that, I
Right.
will be the next Da Vinci.
And
Uh,
everyone,
uh,
right. That's right.
uh,
All right. So wrap it up. What do we do now, man?
what should we do now? That's the final question. Yeah, the final big question, and the answer is, we should carry on if possible. And that's the second. That's the, like, why are we here? We're here to preserve our patterns.
Mm,
And so, what does preserving our pattern means? It means carry on.
yeah.
Yeah, like that. You're doing fine. How do I know you're doing fine? Because you received this code transmission, like that. And if you haven't received the code transmission, well, that's unfortunate, like that. So what should we do now? We should carry on if possible, and improve the code base where we can. And
Those
that's
are
sticking.
words to live by, man. That is,
I feel okay about this.
okay. Yeah. No, it's really nice. Like I thought, well, I don't know how you exactly picked the questions and so forth, but like the fact that you have a pretty insightful and satisfying answer to each of them is
Yeah,
pretty impressive. So
because they
well
are
done.
kind of big questions,
They
and
are.
yeah, we expect to get lame ass answers to them. And so where do we come from? We came from a broken living change, like that. That's not as satisfying as it might be, but to me, that's an example of. But that's the right way to think about it, and so we need to say that to folks so they'll have it in there, so they can hear me now and believe me later,
Mm.
kind of thing, like that. So. Exactly. Uh, well, so thanks so much for coming at me with all this stuff, and for I hope folks, we've gone long here, but hopefully folks won't mind too much, and they can join the conversation as well if they can. I mean, it is
Ooh.
possible to leave comments on the Computing Up page, although it goes through some sort of anti-spam filtering, so it might not be too easy. But they can certainly find join the conversation on the YouTube video, which we'll put a link in, and so on and so forth,
Great.
like that.
Or on, I don't know, Mastodon.
On social media, yeah, we want to call it the Fediverse. So Mastodon is just one program that allows you to connect to this federated universe of many, many, many separate servers, and we call that the Fediverse.
See, I want to
And
say that makes me think of somebody's, is it what Britney Spears's husband at one point or something like that? There was a Federer, or maybe there's a
uh,
tennis player named Federer. I think there's maybe
there,
multiples.
we are so incompetent in popular culture. There's a Roger Federer who was a
Okay.
tennis player.
And
Yeah.
he's in charge of the Fediverse, is what you're saying.
No, there's just
Okay.
Fedi, Fedi, not Federer.
Oh, Fediverse.
Fediverse,
Fediverse
like
meaning.
that.
Okay, I got it. Fediverse
Yeah.
Mastodon. Okay.
Yeah, there you go. Like that. And I wrote the FedI Council priorities, and now all we have to do is figure out how to get FedI Council to exist, and then they can take my priorities, and everything will be fine. Anyway.
Oh,
Okay,
Kevin
man.
Federline. That was who I was thinking of. Federline.
Ah,
That was
Federline, but there is a Federer, isn't there? A
Yeah,
Federer? Okay.
Federer was the tennis player, Roger Federer. You nailed that one. But
Uh,
then Federline was Britney Spears's person.
who's a performer and entertainer or something?
I'm not
We
going to
don't
speak
know.
to that. I mean, I know some things. I'm not going to say it because it seems rude. But he was not beloved, as I
I
understand it.
see. I see. Well, I mean, poor Britney Spears. I mean, she's
Yeah,
had
she's
a
having a
tough
moment
road in a lot
now.
of way. Yeah.
This is what I'm
Uh,
led
um,
to believe.
yeah.
And you know
Okay.
what she should do? She should try to carry on and improve the code base if possible.
Exactly.
And she has in
Exactly.
many ways, I think. Some of her
I
songs
think
are
that's
really
true
great.
too. Absolutely. Yeah, yeah. And that's a good example because again, it's easy to take this stuff in a too pompousy sort of way. Like I have to write an academic paper about the
Mm.
code base, or if I have to write a GitHub pull request or something like that. But, and I feel like I haven't said this well enough yet that, once we get beyond the idea that computation has to be deterministic, there's all of this new lands of ways to talk about things that are absolutely general, supportedly in the nature of computation, in the nature of code, but can rope in, a hit song, a meme, all of that stuff.
Outstanding. Well, I feel like usually you get to say the last word, but since we're mostly talking about you, maybe I should say the last word, which is thank you for thinking about this and sharing it with everybody, because I think there's a lot of great insights in there. So be well, carry on.
Thanks so much. This was Computing Up. Thanks for listening.